Hi, this is lesson 10.3, Define and Use Probability. So our big question here is how can you find the probability that when 5 cards are drawn from a deck, 4 of them will be aces? So look at your frame for 10.3, Define and Use Probability. This is about learning how to find the probability of an event and giving it a value. Okay, so with probability, we're going to write these as a fraction. The so what, let's just fill this in right away. We're going to be talking about theoretical and experimental probability. And what I want you to remember is with experimental probability, you use actual data. Okay, that's the difference here. Experimental probability has actual data. So theoretically, you would know if you flip a coin, there's a 50-50 chance of getting heads or tails. Experimental probability would be when you actually went and did an experiment and used that data as your probability, which if you flipped it 100 times, you may get 49 heads and 51 tails. So that could be a little bit different. Okay, so theoretical probability, when all outcomes are equally likely, the theoretical probability that an event A will occur is P of A. We write it probability of A. It's the number of outcomes in an event A, so how many you want, out of the total number of outcomes. So the theoretical probability of an event is often simply called the probability of an event. So think of this as a probability of how many you want out of how many total are possible. So let's do a problem, and I added my cards on here. They're a little blurry. You can't see it real well just because I know some of you aren't used to cards. So you might want to look at a deck and get used to how many cards, how many types of each there are so that you can do these problems because you'll have a lot of card problems. So using a standard deck of 52 cards, find the probability of drawing a red queen. So red queens, here's a red queen and here's a red queen. So we've only got 2 red queens. Okay, so there's 2 red queens. So 2 that we want out of our total number of cards is 52. So 2 out of 52, and if you reduce that, divide them both by 2, you get 1 out of 26. And you do want your answer as a fraction in reduced forms. Okay? So we have 2 possible ways we could choose a red queen, and then that's 2 out of 52, reduce it to 1 out of 26. Experimental probability now. When an experiment, like I said, we're doing an experiment here, is performed that consists of a certain number of trials, the experimental probability of an event A is given by the number of trials where A occurs over the total number of trials. So we still have our total number on the bottom. Our top is how many times our event actually occurs. So in this problem, exam grades of students in a history class are shown in the bar graph. Find the probability that a randomly chosen student in the history class received a C or better. So they could have gotten a C or a B or an A. They could have had, there's 8 who got a C, 12 who got a B, and 7 who got an A. So our total, our probability here, is how many we want. We want C's, which are 8 students, or B's, which were 12 students, or A's, which were 7 students. And our bottom number is going to be the total. So if you add 3 plus 1 plus 8 plus 12 plus 7, you get 31. So 31 is our total, and that's on the bottom. So if you simplify this, 31's on the bottom, and if you add the top together, 8 plus 12 plus 7, well, that's 27. So our probability is 27 out of 31 because that cannot be reduced. Let's look at the back side of this frame. Okay, finding odds. This is about how we find odds for and against something written A to B. Okay, your odds have to be written in this form, A to B. Do not write odds as a fraction. Write it just like this, A to B. So finding odds in favor. When all the outcomes are equally likely, the odds in favor of an event are the number of outcomes A, and then we put our 2 dots, and the number of outcomes not in A. Okay, so finding the odds against. When all outcomes are equally likely, the odds against are, we just switched these 2 pieces. the number of outcomes not in A, to, the two dots, to the number of outcomes in A. So if it's odds for something, we want the number of outcomes in that first. If it's odds against it, we want the number of outcomes not in that. So here's our example. Okay? It says, a marble is drawn from a bag containing 6 red, 12 yellow, and 9 black marbles. Okay, so if you add those all up, your total is 27. I want to keep that in mind. Okay, there's a total of 27 here. Now, we're not going to use that total as either of our numbers, but our two numbers, when we make odds, should add up to 27. So A, the odds in favor of drawing a red marble. Well, we've got 6 of them that are red. So there's 6 ways that we can get a red. 2, if there's 27 total, then there's 21 ways we cannot get a red. So 6 to 21s would be our odds in favor of drawing a red marble. Next here, we want the odds against drawing a black marble. Okay, so we have 9 black marbles. If we have 9 black marbles, that means we have 18 that are not black. So our odds against has us do what we don't want first. 2, our black marbles, there's 9 of them. So 18 to 9 would be our odds against drawing a black marble. I want you to notice both of these, both times they have to add up to your total, which is 27. So the so what that I want you to remember here, wow, this looks pretty funny. This is your so what statement. Your so what is your two numbers should always add up to the total. Make sure you read carefully too if it's odds for or against. So this is the end of lesson 10.3. It was a pretty quick video. Make sure you start it if you had any questions on anything so that we can talk about them in class tomorrow. And have a great night.